Problem number 4, rolling a dice, a die, one of them. So I'm hoping you're familiar with what a dice is, 6-sided. Probability of rolling a 1 dot would be 1/6. Okay, you think 1 is coming up too often. So this is similar to problem 1. Instead of a coin, now we're talking about dice. You think 1 is coming up too often. It should come up 1/6 of the time. So again, is your friend cheating? You make them roll the die 120 times and 1 comes up 24 times. So is there evidence at the alpha 0.05 level that 1 is coming up too often? Okay, see if you can write down the null and alternative hypothesis on your own right now. So maybe press pause and write something down. Okay, you didn't do that, fine. So the null, so P is equal to something. So just like the coin, right? If it's a normal fair coin, it should be 1/2. So if it's a normal fair dice, we should see 1/6 of the time. Fraction, yes, no big deal. And the alternative, P 1/6, is it a greater than, a less than, or does not equal? Reread the problem. We think that 1, when I say 1, you know when you roll a dice, it looks like that? So that's 1, okay. So you think 1 is coming up too often. 1 is coming up too often. 1 is coming up more than it should be coming up, greater than 1/6 of the time. Okay, so make sure that makes sense. Test stat. I'm just going to use the magic of my calculator. So go to stat, go to tests, go to 1prop z, enter. 1/6. Let's just type in the fraction 1 divided by 6 and hit enter. Oh, thank you, calculator. It comes up 24 times out of 120. So 24, enter, 120, enter. And now we need to figure out the symbol for HA. We put a greater than symbol. So slide over here. So remember the does not equal sign is a 2-tail. So this is a 1-tail and it's pointing to the right. So this is a right tail. It's a 1-tail, yes, but technically a right tail. Hit enter. Okay, so Z 0.979795. So let's call it 0.98. Z equals, do I have to put the Z? Yes, put Z there because there's other test statistics later on. So put 0.98. Critical values, we'll do that later. P-val, the P is 0.16359, 1636. 0.1636. Okay. Move this over here. Let's see. My alpha, did they mention it? If they don't mention it, it's 0.05, but they do say alpha is 0.05, so alpha 0.05. So here's my p-value. If alpha is 0.05, how does that compare? It's greater than. So if it's greater than, if p-val greater than alpha, I would say do not reject. No need for caps. Not sure why I did that. Do not reject HO. So remember, a small p-value means we saw something weird and we would reject HO. So we didn't really see anything too weird. What was the probability of our friend getting 24 1s out of 120 rolls, or something more extreme? Oh, about 16% of the time. Oh, that's not crazy. Yeah, they're probably not cheating. Okay, so we do not reject HO. If you do not reject HO, let's see, it's either evidence suggests or not enough evidence suggests. So if I say do not reject HO, then there's not enough evidence to suggest. Not enough evidence to suggest the alternative, that the proportion of 1 is coming up more than 1/6 of the time. So if you just put it into words, plain English, not enough evidence to suggest that, call it 1, is coming up too often. I'm using the wording they sort of used. So that doesn't always work. Just make sure it agrees with this idea. The proportion of 1 coming up is greater than 1/6 of the time. So not enough evidence to suggest that 1 is coming up too often. Okay, and so I didn't need to explicitly say 1/6 because everyone knows what a dice is. So if it's not a familiar thing like a coin or a dice, you probably want to actually mention the number there. Okay, so hopefully these problems are getting easier. Critical values. Again, we did the whole problem, but the book likes asking for critical values. No big deal. Let's draw a little picture. And we're going to put alpha 05, 5% on the, see how our alternative is pointing to the right there? So on the right side. So on the right side, we have 0.05. So try and find 0.05, and depending on how you do it, on your left tail table, you might find it's either negative 1.64, negative 1.65, but you average them, negative 1.645, but it's on the right side, so it's positive 1.645. Hopefully we're all familiar with that game. So my critical value is positive 1.645. Or, here's how I did it really quickly in my head. Okay, feel free to ignore this, but this is my fancy trick. Visualize, if you will, if you have 5% on the right, what if you had also 5% on the left? Wouldn't that mean 90% in the middle? And doesn't 90% in the middle correspond to a critical value of 1.645? Aha. Okay. Hope these are making sense.